We will do chapters 10, 11, and 12, which are very, very important. And I will warn you, one of my students yesterday said, Miss Lashley, this is hard. And I said, and what I didn't say to the student, but what I am going to say to everyone now is, you're at the end of geometry. It's not going to get easier. Chapter 1 was easy. It was the brand new, just vocab, basic geometry, but now it's building. Everything we've learned is building, right? So you're having to remember stuff from before and use it, your alternate interior angles, your special right triangles, SOHCAHTOA. Everything just keeps building. And these last 3 chapters are not going to be easy. They're not extra hard. It's just not going to get easier, okay? So you're going to have to really buckle down and study. One thing I saw yesterday that I do want to warn you about, and I'm not with you at home, so I don't know what you're doing at home, but one thing I saw in my encore yesterday was a student studying for their test by just staring at my answer key. That is not a good way to study. To study, you have to practice the problem. You have to write it down. You have to try to work it. If you're just looking how someone else worked it, that's giving you a false sense of what if you know what you're doing. Never take my answer key and just look at what I've done. Put it to the side, take the blank review, try working the problem, then go back if you're having trouble, look to see what I did. Then try it again. Keep trying until you can do it on your own. And that's what you are just going to have to do. Persevere, keep trying until it's really clear. Okay? I'll encourage you one more time for probably the 15th time this school year to use me. If you are having trouble, call me, text me, come in to Encore, come in before school, go to tutoring. It's my job to try to make it clear to you, but when you leave my classroom, it's up to you to seek out that help. I can't just call you every night saying, hey, Kirsten, do you need some help tonight? I'm just worried about you. Got 152 kids. I'm not going to do that, but I am going to be available if you need me. So please take advantage of that. You may not realize, it's kind of those things when you're young, you don't realize when something's good until you don't have it later in life and you look back on it. But you're going to eventually have professors and other teachers that won't let you call them or text them. You may already have teachers like that. And you're going to find that that would have been nice if you would have had it and later wish you would have taken advantage of it. So just encouraging you to please do that if you need me. All right, chapter 10. So chapter 10 is not going to have a vocab test, but it is going to have a formula test. So there are a lot of formulas that we're going to have memorized. Some of those you should have learned way back in middle school, elementary school. My 5th grader already knows some of these formulas. You were introduced to them early on. Whether or not they've stuck with you, that's fine if you've forgotten. These formulas in purple we learned back in chapter 1. So we reviewed them because they should have been things you learned before, but we learned them in chapter 1. They were on your chapter 1 test, so what's in purple is not new. If you have not retained that, you're going to have to go home and study that. What's in green is new for today. So we're really only learning 4 new formulas today. But you actually have 11 up here that you need to know when you walk out the room today. So make yourself a good formula sheet and then start practicing. Quizlet would be a great way. Type in the name, type in the formula, start practicing your formulas today. The day that we review for the test, which will not be until after spring break, the day we review for the test, we will take a formula test where you walk in just kind of like a vocab test. The difference will be it will not be matching. It will be just fill in the blank. Write the formula for area of a triangle. Write the formula for area of a square. Because when you take the test, if you don't know the formulas, it's not going to do you any good to take the test. You have to have the formula before you can work the problem. Does that make sense? So I'm going to push you hard on the front end to start memorizing those formulas so that when you come in to take the test, it's not the formulas that are causing you problems. You're just plugging in the numbers and working the problem. All right, so let's see what you knew. What's the area formula for a triangle? 1/2 base times height. If you didn't know that, write it down now. And I'm going to be really picky about this. Sorry, so I'm going to write it the way I'm going to be picky about it. Make sure and put A equals 1/2 base times height. And you may think that's silly, but the reason I'm going to be super picky is because they're oftentimes going to give you the area and ask you to find the base or the height. And if they do that and all you have is 1/2 BH, you can't work the problem. You need the capital A there for area. Okay? So I'm going to be real picky, put A equals. All right, area of a square. What's area of a square? Length times width is not the area for a square, although that will work if you know the length and the width of your square, but there is a more simplified formula, S squared. In a square, it's special. The length is the same as the width, and so we call it the side length, and it's side squared. And that's important because if you write it as length times width, and then they give you the area is 16, you can't solve that problem if you have two different variables. But if you have 16 equals S squared, what's the side length? 4. Do you see the difference? So sometimes they're going to give you the area and ask you to work backwards, and so you have to know the correct formula for it to work. Whereas if you were in elementary school, you would have just plugged in the fact that the length and the width were the same, and it wouldn't have been a problem. All right, rectangle. What's my formula? Length times width is fine. This book is going to put base times height. It doesn't matter. I won't count it wrong if you put length times width, but I'm just going to be consistent with what they're going to use for base and height. All right, circle. Say it again. Pi r squared. Area equals pi r squared. That formula is one of the most missed formulas. Here's how I remember it. What do we know about the units for area? Units are always squared. So what I do is I remember that since the units are squared, the formula has the r squared for area. And the reason most students mess it up is because when we come over here and talk about the perimeter, it's very closely related, right? All right, perimeter for a square. What's my perimeter formula? S times 4 or 4S. Again, I'm going to be real picky. Put capital P equals. Capital P equals because if they give you the perimeter and want you to work backward and find the side length, you're going to have a place to put the perimeter. All right, rectangle. What's the perimeter formula for a rectangle? 2L plus 2W. Again, since we used B and H, I'm going to use B and H. So 2 base plus 2 height. What's the perimeter formula for a circle? 2 pi r, and we don't usually call it perimeter. What do we call it? Circumference. So instead of putting a P there, I'm going to put a C for circumference. 2 pi r. And so again, I'm going to point out, do you see how they both have a pi, they both have an r, and they both have a 2, right? It's where the 2 goes that makes all the difference. So just remember, the one that has the r squared is the one that has the units squared, and that's area. A lot of students made a mistake in chapter 1 and wrote this, 2 pi r squared. There's not two 2's in either formula. There's only one 2. So it's either 2 pi r or pi r squared. Okay? So be real careful. Those are the ones you should know already from chapter 1. These are the ones we're going to fill in today. Does anybody know any of these formulas right now off the top of your head? Very good. Parallelogram is base times height. Oops, again, I keep not doing what I'm going to expect you to do. Area equals base times height. Anybody know another one? Rhombus is not S squared. Good idea, though. Any other ones you think you know? Okay, as we go through them in the notes today, we'll fill them in on our formula sheet. So that's okay. These are, like I said, new ones that I didn't expect you to know. These are the ones that I was hoping you would know. And as a class as a whole, we did come up with all of those. You may not know them individually, but that's something you can work on. Okay, I'm not going to approach it too much like they're going to in the notes. And let me pass those out to you. That would be helpful. Sorry. In the notes, though, they're going to go through and discover the formulas. Spend some time trying to get you to understand where these formulas come from. We'll look at it quickly, but I'm not going to spend a lot of time trying to develop or discover the formula. We will look at, see where it came from, and then we're just going to move on and try to practice using it correctly. And Michael, will you lay this back there for Angelina? And Trey, will you lay one back there for Landon? Okay, so here we go. First thing that's going to be super important is They're going to ask you to find the area of shapes that are not just triangles, circles, squares. So for example, they may ask you to find the area of an ice cream cone that looks like this. If I want to find the area of an ice cream cone, what am I going to have to do to find the area of that shape that is not just one of those? Okay, split it into two different shapes. So what two shapes would I have here? Very good. Triangle and a half of a circle. So I would have to find the area of the triangle and add half the area of the circle. Does that make sense? Okay, so what we're using there is called the area addition postulate. It basically says the area of a region that isn't just one shape or another will be equal to the sum, which is where we added, of the areas of its non-overlapping parts. That's key there. You don't want to add a part more than once. So when Thad said take half the circle, that was important because even though your ice cream is probably going all the way down inside your cone, or you hope it is, hope they give you a good ice cream cone, but you don't want to count that ice cream that's inside the triangle. Does that make sense? Because you're already taking care of the triangle. And in real life, this would be three-dimensional, and we would actually be talking about what three-dimensional shape is your actual ice cream. The ice cream part. What do we call that in 3 dimensions? A sphere. And then the triangle in 3 dimensions, what would that be? A cone. And so we're going to be talking about spheres and cones coming up next chapter, not this one, but we're just talking 2-dimensional in chapter 10. Everything in chapter 10 is going to be 2-dimensional. So we're going to flatten out our objects, and then in 11 and 12 we're going to make them bigger. Okay? All right. So here is your first formula that Tate gave us, and that's the area formula for a parallelogram. They're going to remind you that for a rectangle, this is your formula, base times height. Here's the thing, though, in the rectangle, the length or the bottom of it is your base, and the left side or your height, width, is your height. In a parallelogram, what they're going to do is they're going to cut off a piece of that rectangle. So they're going to cut off this little triangle, and they're going to reattach it over here. And when they do, it makes this parallelogram. Do you guys see that? So it's going to have the same area, base times height, as your rectangle, but the height is no longer the left side of your triangle. So be really careful. This will never be your height. That's diagonal. We talked last chapter that height is always perpendicular. You can draw your height inside that parallelogram anywhere. It could go here, it could go here, it could go here, it could go right here on this triangle. Anywhere in between those two bases, as long as it is perpendicular. So the area for a parallelogram will also be base times height. Just being very careful that you remember that your height is not this side. Now here's where last chapter is going to come back to help or haunt you. They may not give you the height. You may have to draw it in and make this little right triangle. And then they may give you this distance or both, where you have to maybe do Pythagorean theorem to find your height. Maybe it's a special, Dad, put it away. Maybe it's a special right triangle and you have to use that to find your height. Or maybe they give you enough information to use SOHCAHTOA to find your height. So you may have to use that stuff from last chapter. Does that make sense? Okay, so it's going to get a little harder because you're going to have to find some of these things. They also remind you of some of your other formulas that we already put in our paper. The area of a square, the perimeter of a square. Those are also in your notes here. So again, I'm going to emphasize this. Pay attention, read this with me. The height of a parallelogram is measured along a segment perpendicular to the base. So when you're looking at your parallelogram, your height could be here, but your height could also be outside your parallelogram as long as it's perpendicular to the line that contains the base. So this could be your height. Does that make sense? So from one base to the other base, perpendicular is your height of your parallelogram. Okay, super important that you understand what the height is or you'll get lots of problems incorrect. Height will always be perpendicular. All right, and then these formulas we already wrote on the board again, so they're also in your notes. Perimeter and for a rectangle. All right, so now we're going to look at our first kind of problem, where they want us just basically to apply the formula for area of a parallelogram. I'm going to be super picky on the test. If you want partial credit, you have to write the formula down first. If you don't write the formula down first and you get the answer wrong, I will not give you partial credit. If you don't write the formula down but you get the answer right, I'll still give you credit. But if you get it wrong and you did not start with the formula, I will not give you partial credit. Are we clear? So that's why I'm going to be so picky, because knowing the formula is basically the majority of what you have to do. Then you're just plugging numbers in. So always start with your formula. What's our formula for parallelogram? Base times height. Say it, write it, it'll help it stick. Okay? Look at your picture. Be very careful. What is the base and the height of this parallelogram? Do we know the base? Do we know the height? What do you think? Okay, if we know the base but not the height, what are you calling the base? Say it again, Thad. Okay, so you could let 11 be your base, but if that's your base, then these are your two parallel bases. So your height has to be perpendicular between them. So that means that 30 is not the height. 34 is diagonal. Your height will never be diagonal. So that means the perpendicular distance between these two bases is right here, and we're going to have to find that height. Now, I want to make sure you're clear. You could have let 34 be the base, but then the height would be the perpendicular distance between these two parallel bases. Do we know that height? No, and we don't have enough information to find that height. So we're not going to let 34 be our base. We're going to let 11 be our base, so that is right. Let's plug that in, 11. But now we're going to have to find our height. So this goes back to what we've learned before. In a parallelogram, what did we learn about opposite sides? They're congruent. So if this is 34, then this is also 34, right? Okay, and so what could we use there to figure out x, which is our height? Pythagorean theorem. So we're going to use our Pythagorean theorem. Somebody set it up for me. Very good, Emerald. X squared plus 30 squared equals 34 squared. Remember, your C is always across from the right angle. That's always your hypotenuse. So 30 squared, I know, is 900. What is 34 squared? 1,156. Okay. And then what do we do to solve for x squared? Subtract 900. And that gives us that x squared is equal to 256. And then what do we do to get x by itself? Take the square root. And so then we type in the square root of 256, and what do we get? 16. So that means our height is 16, and now we can come over here and plug that in for the height in our formula. And then we're just going to multiply 11 times 16. So the formula part should be really easy if you know the formula. The hard part's going to be finding all of the measurements you need. And that's just going back to what we've learned before. What's 11 times 16? 176. Are there units in our picture? Yes, millimeters. And if I'm finding area, what will my units always be? Squared. So this should be millimeters squared. Questions on the first example? All right. Next problem. So this one's going to take us back to Algebra 1, and I think you're going to find that a lot of the trouble with Chapter 10 is going to be either memorizing your formulas or having good algebra skills. If you've got good algebra skills and you can memorize your formulas, it won't be that difficult of a test. So find the height, that's what we're looking for, of a rectangle in which the base is 3 inches and the area is 6x squared plus 24x minus 6 inches squared. Every time I'm going to tell you to start with your Formula. So what shape are we talking about? Rectangle. What concept with rectangle? Area or perimeter? Area. They give us the area. So let's start with our formula. What's the formula for area of a rectangle? Base times height. Then I'm going to advise you to plug in everything you know into your formula and then try to work backwards to find what you need to know. So the area is 6x squared plus 24x minus 6. So we're plugging all of that in for A. Corbin, you with me? Okay, I would write it down so you have good notes. Do we know the base or do we know the height? Base. So what am I plugging in for the base? 3. But I don't know the height, so that's what I'm looking for. So what would we do if we were trying to work backwards and solve for h? I don't want to add 6. That would be moving it over to the h, and I'm trying to get h by itself. So I want to get rid of stuff that's by the h. Divide by 3 is correct, Matt. We want to get h by itself, and right now h is being multiplied by 3. So the opposite of multiplying by 3 would be to divide by 3. Question? But we're not trying to solve for x. We're trying to solve for h. Find h. So that means our answer is still going to have an x in it. So on the test, I will make it clear, Reese, and I will add this phrase, in terms of x. So if you see that on your test, that means you're still going to have an x in your answer. Don't stress about that. You're not trying to find x. You're just trying to find whatever thing they ask you to find, and that you may still have an x in your answer. Does that make sense? Okay. So Matt's correct. We want to get h by itself, so we're going to divide by 3. So when you divide by 3, make sure you divide every single term by 3. So you're going to divide the negative 6, the 24x, and the 6x squared. Everything gets divided by 3. What is 6 divided by 3? 2. So we have 2x squared plus 8x minus equals h. And all it said was solve or find the height. So once you have the height by itself, you're done. The only problem is we're missing our units. What units should we have here? Should it be inches or inches squared? Are we finding area? It's just the height, so it shouldn't be inches squared. It should just be inches. The only time you're going to put inches squared is if you're finding the area. I can show you in the work where we would have had that to help you. So I'm going to just write this down up here. And if you need to, include it in your work. This was inches squared, right? And this 3 was inches. So when we divided by 3, we divided by 3 inches. And so the inches squared and the inch canceled. And we were just left with inches. Does that make sense? Questions? Kevin? That's your answer. It just said find h, find the height. And again, I will make sure on the test that I put in terms of x if you're going to have an x left in your answer, so it doesn't make you feel like, oh, I'm doing something wrong, I still have an x. Okay? Are we good with that? Okay. Ask if you're not. This is the beginning of a new chapter, new chance for better grades. All right, same kind of idea here. This time they want us to find what? Perimeter of what? Rectangle. Let's start with our formula. Perimeter equals what? 2b plus 2h. Now, I didn't ask this a while ago. If they just say find the perimeter and they give you all the information you need, you don't have to use a formula. What does perimeter mean? How do we find perimeter? Say it again. What do you mean by count it? Okay, so when you're saying count it, you mean we're adding, right, all of those side measures together. Okay, so perimeter just means to add all the sides. So if you know all the sides, you can just add them all up. The problem is this chapter is not basic chapter 1, where they're going to give you the 2 side links and you can just add them all up. You're going to have to be using both formulas and working backwards, so it gets a little harder. But if it did just say find the perimeter, by all means, just add up all your sides. So don't get so stressed that all of a sudden you can't remember the formula. but you know how to work the problem, then work the problem. Okay? Thank you. All right, so find the perimeter of the rectangle where the area is this. So first of all, go over to your rectangle. What do we know about the rectangle? Say it again. The base is 21, so we know the base. Do we know the height? No. It's a rectangle, and base and height are not the same. So we know the base, so we could go ahead and plug that in. 2 times 21 plus 2h. But then we're stuck. We can't find the perimeter unless we know the height, right? Okay, so now we're going to have to use the other thing they gave us in the problem. They told us the area. Again, I'm going to put here that you can leave your answer in terms of x. And again, I will put that on the test so you don't get confused. So we're going to start with our area. So when you get to a point and you're stuck in your work, look back and see what else did they tell me. They told me the area. What's the area formula for a rectangle? Base times height. So now you're going to plug in everything you know and see if you can find your height, because that's what you need to answer this question. So do we know the area? Yep, it's all of this, so let's plug it in. 79.8x squared minus 42 equals, do we know the base? 21. Do we know the height? Nope, so we leave it h. Okay, this is just like the previous problem. What are we trying to find here? H, so that we can ultimately find what? The perimeter. Okay, so how do I solve for h? Divide by 21. Again, make sure you divide everything by 21. So we're going to divide every term by 21. What is 79.8 divided by 21? 3.8. So we have 3.8, don't forget your x squared, minus, what's 42 divided by 21? 2, equals, and then the 21's cancel, so that is our value for h. Are we okay with what we got for h there? 3.8 squared, 3.8x squared minus 2. So what do we want to do with that value for h? Plug it in over here into our perimeter formula. So now we're going to take all of this and plug it in right here for h. So we started with what they asked us to find, but we hit a roadblock. We didn't know what h was. So then we took the area that they gave us and wrote that formula down and solved for the height. Now that we know the height, we can go back to where we were and plug it in. So we have 2 times 21 plus 2 times, and then we're plugging all of that in. 3.8x squared minus 2. What do we do from there? We need to distribute. What's 2 times 21, first of all? 42 plus, and then we're going to distribute the 2 to both terms. So what's 2 times 3.8? So we have plus 7.6x squared. And then what's 2 times negative 2? Negative 4. What do we need to do from there? Combine like terms. So we've got a 42 and a negative 4. It's on the same side of the equation. You're not moving it from one side to the other. You're just adding those together. What's 42 minus 4? 38. So really the way you should write your answer is perimeter equals, putting your x squared stuff first, 7.6x squared plus 38. In Algebra 1, you should have learned that you should always write your equations in descending order of exponents. Did you guys talk about that in Algebra 1? So x squared, then x, then your constant. And again, in terms of x means you can still have an x in your answer. Hold on one second, Ruben. What will be my units here? Centimeters, not centimeters squared? Correct, just centimeters because we're just finding perimeter, not area. Ruben. Probably not, but it's a really bad habit to get into because when you get into Algebra 2, they probably will. And that's where you're headed next year, so it's better to get in a good habit now so it makes next year's algebra much easier. Okay? Any questions? You should, again, I probably won't count off for it, but the entire expression is in centimeters. It's not just the 38 that's in centimeters. And so when your units go with your whole expression, they put it in parentheses. So again, just a good habit to get into to have correct notation. Any other questions? So if you had perimeter is this and you had this correct, no. But I'm just telling you that if you want me to give you partial credit, I'm not going to give you partial credit unless you started with your formulas. Okay? But if you can work the problems perfectly and you don't need to start with your formula, more power to you. But I will say in the past, typically that's where students make a mistake is they start trying to work it without writing their formula down. So I'm just trying to encourage you to write your formulas. And I'm telling you that if you write your formula correctly and then make some mistakes, I can give you partial credit. But if you don't write your formula correctly or you don't write it down at all, I can't give you partial credit. Okay. All right, so our next formula. So you guys had the area of a triangle, but the area of the trapezoid we did not know. Area of a trapezoid is much like area of a triangle, but the problem is in a triangle you only have one base. How many bases do you have in a trapezoid? 2. Your bases are your 2 parallel pieces. So when I look at my trapezoid here are my 2 parallel pieces. So these are my 2 bases. So instead of doing 1/2 base times height, we're going to do 1/2 sum of the 2 bases times the height. So it is 1/2 base 1 plus base 2 times the height. So on your formula sheet, make sure you add this down. Area of a trapezoid, A equals 1/2 base 1 plus base 2. I'm running out of room. I'm going to rewrite this. Times the height. So area equals 1/2 base 1 plus base 2 times the height. Okay, so very similar to a triangle, but instead of coming to a point, it levels off again, so you have to add those 2 bases together first. All right, so we're going to jump right into a very simple problem. I want you guys to do this one on your own, and then we'll check it. Make sure your phone's off, please. Be careful, Matt. No, this is just your... You're going to have like, work to get here. Okay, you're just going to set up that. Just make sure you show me work, okay? Hands up if you have an area or an answer for the area of the trapezoid. Okay, let's check. So formula should have been 1/2 base 1 plus base 2 times the height. Plugging in what they gave you, base 1 was 8, base 2 was 5, and the height was 6.2. And again, I can't say it enough, I strongly encourage you to write the formula down because it never fails. Someone accidentally writes something like 6.1 instead of 6.2. but they do it in their calculator wrong. They don't write any work down. I can tell that they've just made a small mistake, but no work means I can't give you partial credit. So write your formula, plug in what you did, and then if you make a mistake on your calculator, at least you can get the majority of the points because your work was all there. All right, so then you have half of 13 times 6.2. Remember, order of operations, PEMDAS. So you're working inside those parentheses first, then doing exponents, then you'll multiply and divide from left to right, and then you'll add and subtract from left to right. So what did you guys end up with for the area? Okay, I heard a couple different answers. Say it again. 40.3. Okay, so did you type in 1/2 of 13 times 6.2? You got 42.25. Okay, I'm going to put the calculator up here and let's make sure we all know how to type the things in on our calculator because we're having some trouble. Okay, did you guys type it in? Did you add 8 and 5 first? Raise your hand if you added 8 and 5 first. Okay, so if you added 8 and 5 first and got 13, you should have typed in either as a fraction, 1 divided by 2, or you could go to alpha y equals and type in a fraction. And then that's times 13 times what? 6.2, which would be 40.3. So double check your math in the way you typed it in. If you typed it in as 1/2, and then you typed in parentheses 8 plus 5, and then times 6.2, you should still get 40.3. Anybody not understand where they went wrong who did not get 40.3? Okay. All right, I'm going to go back then. And it's 40.3 what? Were there units? Inches squared because it is area. All right, any questions on that one? Mm-hmm. And you can do 1/2 of 8 is 4 and 1/2 of 5 is 2.5. Just be careful that you don't distribute the 1/2 to the 6.2. 1/2 is multiplied by what's in parentheses. It's always left to right. But it's good habit to get into to do what's inside your parentheses first, just because as your math gets harder, that could make a difference for you. But totally correct. All right, moving on. Next question, same kind of idea, but we're going to work this one together. Find the base of the triangle in which the area is given. So again, you're looking for capital B, and on the test, I would put in terms of X, just so it doesn't make you feel crazy if all of a sudden you have an X in your answer. So find the base of the triangle given this area. What formula do we need to start with on our paper? Area of a triangle, which is A equals 1/2 base times height. Plug in what you know, solve for what you don't know. So do I know A? Yes, that is 15x squared. That equals 1/2 of, do I know B? Nope, that's what we're trying to find. Leave it B. Do I know H? 5x, so plug in 5x. Okay, this is going to come down to your algebra skills again. A little tougher here. So we're trying to find B. What would you guys like to do to start trying to get B by itself? Okay, Reese said divide by 5x. Is everybody okay with dividing by 5x? Okay, because it's times B, right? So I'm going to divide by 5x. Be very careful over here on the left. What's 15 divided by 5? 3. What is x squared over x? Just x. Remember, x squared means you have x times x. And if that's over x, then one of the x's cancel, but you still have one x left. Or what you should have learned in Algebra 1 is when you have x squared over x, you subtract the exponents. So 2 minus 1 is 1. Are we good with 3x? Anybody not understand how to get 3x? Okay, equals, what are we left with over here? 1/2 B. Okay, we still want to solve for B, so what do you want to do to get rid of that 1/2? Okay, I heard two different answers. I heard divide and I heard multiply. If you said divide, what are you dividing by? 1/2. If you said multiply, what are you multiplying by? 2. So dividing by 1/2 is the same as multiplying by the reciprocal. So you can either do 3 divided by 1/2, or you could just multiply both sides by 2, which I find easier. And what do we end up with for b? 6x. And what are our units? Centimeters. Not centimeters squared? Why is it not centimeters squared? Because we're finding the base, not the area. Questions? Okay, so formulas with our algebra. I'm telling you, those are the two hardest parts to this lesson. Being able to work with our algebra skills and then formulas. All right, so one more here, and then we're going to talk about the last two formulas, rhombus and kite. So find base 2 of the trapezoid given the area. I'm going to let you try this for just a minute on your own. Start with your formula, plug in what you know, see if you can find base 2. And then we're going to talk about it. Landon and Angelina, one thing I should tell you guys is that you missed is we're going to have a formula test when we review for the chapter test. Instead of a vocab test this chapter, we'll have a formula test. So the bell work that you guys missed out on was to get out a sheet of paper and write down all of the answers to those formulas. The ones in purple on the left were from chapter 1 that you should have already learned this school year. The ones in green on the right are new today. We've only learned 2 of them so far, and we're getting ready to learn the next 2. So before you leave today, either write those down or get out your phone and take a picture of that and write it down later so you'll have it to study with, okay? Oh, I'm sorry, Angelina. Might help if I'm not standing in the way. Gonna give you about 1 more minute. Keep working. Just trying to see how far you can go and if you get stuck, where you get stuck at. Okay, for time purposes, I'm going to go ahead and pull us back. That wasn't a lot of time, but we should have started with what? Formula for area of a trapezoid, which we wrote down on the board is A equals 1/2, add the 2 bases, base 1 plus base 2 times the height. Similar to a triangle, but now you have 2 bases. So 1/2, add them, times the height. All right, so then plug in what you know. The area is 231, so it goes in for A. That equals 1/2 of, do we know base 1? Yes, we do. What did they tell us base 1 was? 23. Remember, your bases are your 2 parallel sides. So they're calling this base 2, which means we know base 1. So base 1 is 23. Oops. Do we know base 2? No, so we're going to solve for base 2. And do we know the height? Yes, and notice how they drew it outside the trapezoid but perpendicular. Remember, it could have been drawn inside the trapezoid here. And again, I'm going to remind you, if it was, or if you wanted to put it over here, you now have a right triangle that you may have to solve for your height on some of your problems. So just don't forget that your height can be transported anywhere if you need to, as long as it's perpendicular. It's just Yeah, if it's drawn like that perpendicular, you can assume that that's going all the way to that vertex point, okay? So not trying to make it too crazy difficult. And if you're unsure about that, just ask me. Are we good? All right, so now we have this, and this is the part where you could work this a couple of different ways, so depending on what's easier to you. So somebody tell me what you thought to do first. Divide by 11, that's fine. So the opposite of multiplying by 11 is to divide by 11. So we're going to divide this side by 11 and this side by 11. If you do that, you're left with what? 21. So 21 equals 1/2 of 23 plus base 2. Any questions on how we did that? Okay. So what did you decide to do from there? Distributed the 1/2. Anybody do anything different besides distribute the 1/2? Okay, I will tell you it's fine if you want to distribute the 1/2, and I'm going to work it that way. But what could we do instead of distributing the 1/2? Say it again, Caleb. Multiply by 2, which is the same as dividing by 1/2. If this whole thing is being multiplied by 1/2, the opposite of multiplying by 1/2 would be to divide by 1/2, which is multiplying by 2. To me, that would be easier here than distributing the 1/2. But I'm going to work it both ways. So I'm going to distribute the 1/2 just because that's what Reese said he did. So I have 21 equals, what's half of 23? 11.5 plus 1/2 of base 2. Remember, you have to distribute it to both if you're going to distribute it. Okay, if I do that, what do I do next? Subtract 11.5. What is 21 minus 11.5? 9.5. So I have 9.5 equals 1/2 of base 2. And then what do I do to solve for base 2? Divide by 1/2, which is the same as multiplying by 2. So I'm going to multiply both sides by 2. And what do we get for base 2? 19. And it's 19 what? Millimeters, not squared because we're not finding the area. Would you like for me to work it without distributing the 1/2? Okay, so if I didn't distribute the 1/2, so that means I'm back at this step, but I'm not going to distribute the 1/2. So make sure you're with me and you're not confused, thinking, why is she doing this thing again? So 21 equals 1/2 of 23 plus base 2. The opposite of multiplying by 1/2 would be to divide by 1/2, which is the same as multiplying by 2. So I would multiply both sides by 2. It causes that 2 and 1/2 to cancel. What's 2 times 21? 42 now equals 23 plus base 2. Then what do we do to solve for base 2? Subtract 23. And 42 minus 23 is 19. Just a little bit easier. Oops, that was millimeters. But works either way. So whatever makes more sense to you. Questions? Okay, let's learn our last two formulas. So the last two formulas kind of go together because they are the same for both shapes with one exception. Think back to chapter 4. And this chapter is going to be a little challenging in that fact that we're talking about quadrilaterals, and we learned all about their properties in chapter 4. So if you forget any, remember you have a big detailed property sheet that you guys made way back in chapter 4 about all your properties of your shapes. But for a rhombus, what is a rhombus a type of? Rhombus is not a type of square. A square is a type of rhombus. A square is always a rhombus, but what is a rhombus always? A parallelogram. Do you guys remember our Venn diagram where we drew the shapes and we talked about parallelograms? And in the parallelograms, we had the rhombuses and the rectangles. And together, those made the... What is a rhombus and a rectangle? A square. So a rhombus is also a parallelogram. So I want to warn you that a rhombus really has two options for its formula. One option is the same as the parallelogram because it is a parallelogram. So a rhombus, write this down, could be area equals base times height. Put that on your formula sheet. because I'm going to ask you for both formulas for the rhombus. But that formula is only going to be useful if you know the base and the height. Most of the time in your rhombus, they may not give that to you. So the second option for the rhombus is the same as the formula for the kite. And the reason that they have the same formula is because if you remember back to chapter 4, your diagonals in a rhombus and in a kite were what? They made right angles, so they were perpendicular. The diagonals in both the rhombus and the kite were perpendicular. The diagonals in the rhombus and the kite were perpendicular. But in the rhombus, when they were perpendicular, they actually made 4 right triangles that were all what? Congruent. Because in the rhombus, all 4 sides were congruent. But in the kite, it made 4 right triangles, but they weren't all 4 congruent. How many were congruent? 2 pairs, right? These 2 would be congruent because their sides were congruent, and these 2 would be congruent because their sides were congruent. Is this coming back to you? So, in your rhombus and in your kite, the reason they have the same formula is because their diagonals are perpendicular to each other. And that means that their formula turns out to be 1/2 diagonal 1 times diagonal 2. I'm going to warn you that this formula is most often missed because it's similar to the trapezoid formula in that you've got a D1 and a D2. But in the trapezoid formula, what do you do with the B1 and the B2? You add them. What do you do in this formula with D1 and D2? Multiply them. So important. You may want to make yourself a note. You are multiplying D1 times D2. It's 1/2 D1 times D2. 1/2 D1 times D2. Kite, same thing. 1/2 D1 times D2. So you're going to multiply from left to right in order. So 1/2 of D1 times D2. You are not distributing. Good question. I think you guys could hear Peyton, but she said, do you just take half of D1? Yes, the only time you distribute is when you have a plus or minus sign. So you're just multiplying from left to right. Half of D1, whatever that is, times D2. There's no distributing process. Are we clear? That's totally fine. You can do D1 times D2 first, then multiply by 1/2. That is also perfectly fine. And the other thing I didn't say a second ago back on this little slide, just to point out, is not only are the diagonals perpendicular, but remember that in the rhombus only, the diagonals also bisect each other. Okay, but that's not true in the kite. In the kite, only one of the diagonals gets bisected. The other one is not obviously split into 2 congruent parts, so it's not bisected. So the rhombus also had diagonals that bisected each other. But you know that because all 4 triangles are congruent in the rhombus, so obviously those distances have to be the same. Okay, we got a couple problems to try with our new formulas. So, it says find D2 in a kite if they give you D1 and the area. Every problem so far today, what are we starting with? Formula, write it down. We want the what formula for what shape? Area for a kite. So area equals what? Okay, and again, I'm going to stress it's D1 times D2 times 1/2, not plus. It's plus in the trapezoid formula. It's multiplication in the kite formula. Plug in what you know. Look for what you don't know. What goes in for A? 238. Do we know D1? Yes, so it's 1/2 times 14. Do we know D2? No. Now it's all about your algebra skills. Can you solve for D2? So what do you want to do first? I would probably take half of 14 too. To me, that's the easiest way to do it. So what's half of 14? 7. So we have 238 equals 7 times D2. Remember, there's no plus sign, so you're not distributing that 1/2. Okay, how do we get rid of the 7 so that we can solve for D2? Just divide by 7. So diagonal 2 is equal to what? 34, and what are the units? Inches, not squared, because we're not finding area. That one was pretty easy compared to some of the other ones we've had so far. Are we good there? Okay, we should have 2 more on the back. Is that, we're not going to do the very last word problem. So 2 more on the back, is that correct? Okay. So let's see if we can get through those. So this one says find the area of the rhombus. This one's going to come back to Algebra 1 skills again. But where are we going to start every problem? Formula. So we're finding the area of a rhombus. What's our options? A equals base times height, or okay, here's where you're going to look to see what are they giving me information about. When you look at the picture, do they give you any information about the base or the height? No. What's this information they're giving you? The diagonals, diagonal 1 and diagonal 2. So which formula do you think we need to use? The second one. So you're just looking to see what do I know, and then that helps determine what formula to use. Most of the time you'll be using the 1/2 D1 times D2. But every now and then they may give you information about the base and the height. All right, be careful. I want to stress this. If they did not have D2 equals and D1 equals and they just had this arrow drawn pointing to here, they would be referring to only this piece right here. If they did not have D1 equals and it was just this, is everybody with me? So if that's the case, what would the whole diagonal, how would we find the whole diagonal if this was just pointed to this little piece? Multiply it by 2 because this is a rhombus and the diagonals bisect each other. Okay? But if they tell you D1 equals, then they're telling you the whole diagonal is that. Does that make sense? Okay, so now we're just going to plug it in. So area equals 1/2 of, what's D1? 8x plus 7 times, what's D2? 14x minus 6. And now we're back to, can you do the skill you learned in Algebra 1? What do we have to do when we have a binomial times a binomial? Distribute, and your Algebra 1 teachers may have used the word FOIL, okay? Here's my advice. I would do what I think it was Ruben said maybe, I would multiply D1 times D2 first, and then I would worry about distributing that 1/2. I think it'll be easier for you in the long run if you do D1 times D2 first. So I'm going to leave the 1/2 and I'm going to multiply the binomial. Most of you did not do this correctly when we had the bonus question where you had to FOIL. So be careful. When you're distributing the 8x to both the 14x and the negative 6. That's where you get the first and the outer in the word FOIL. You do not have to use FOIL if that doesn't make sense to you. Just distribute the 8x to both. So what do we get for 8x times 14x? Very good, Andy. 112x squared. Don't forget that x times x is not x. All right, what is 8x times negative 6? Negative 48x. Then you're going to go back and do your inner and last by distributing the 7 to both. So I know a lot of teachers do it up here, but I do my 7 down below. So 7 times 14x and 7 times negative 6. So that's where we get the inner and the last if you're using FOIL. What's 7 times 14x? 98x. And then 7 times negative 6. Negative 42. Okay? From there, we're just going to combine like terms, and then we'll distribute that 1/2. So what can we combine in the middle here? Negative 48 and positive 98. So we have 112x squared plus 50x minus 42. And then what do we need to do? Distribute that 1/2, because now we've got it completely as far as we can go. We just need to distribute our 1/2. So 1/2 times every single term. So what's half of 112? 56. Don't forget your x squared. Plus, what's half of 50? 25. Don't forget the x. And what's half of negative 42? Minus 21. And since this is area, what are our units going to be? Centimeters squared. So this whole thing is centimeters squared. Not necessarily. They may give you all the numbers and you just plug it in and find the area. But this chapter makes you go back and review your algebra skills to show you that what you're learning isn't always in real life going to work out where you know all your measurements. You may know your area that you know how big of an area you want to make, but you don't know what to make your dimensions. So you're trying to figure those out. Does that make sense? Okay. Last question. We got about 6 minutes. This one is probably the hardest one out of all of them, so let's see if we can at least just set it up. It says find the area of the kite. So every problem today, where do we start? Formula. So area for a kite is what? 1/2 d1 times d2. Okay, guys, don't zone out on me now. Make sure you look up here at the picture. When I look at this picture, do I know the lengths of both diagonals? No. In my kite, we're going to assume by looking at this picture, tell me if you would agree, that this side is congruent to this side. By definition, we know that every kite has 2 pairs of congruent sides. So would you agree those 2 look congruent? And these 2 look congruent. Okay. We know this 28 is referring to this piece of the diagonal. But we need to find this other piece of the diagonal. And remember that in a kite, both diagonals are not bisected. That's only true for a rhombus. In a kite, though, we do know that the diagonals are perpendicular. And that these 2 triangles are congruent, and these 2 triangles are congruent. Does that make sense? Okay, so if we can find this length y, what do we know about this length over here? It's the same, so it's okay if I put a little y there? Are we okay with that? But this length 28 is not the same as this length up here, right? Because these 4 are not congruent. If this were a rhombus, it would be, but not for a kite. So we've got to try to figure out the length of y so we can double it to get one of our diagonals. And then we need to find the length of x so that we can add it to 28 to get the other diagonal. How are we going to find those measurements? Pythagorean theorem. So remember, let's find one triangle that we have 2 sides for. So would you agree in this triangle right here that we know this side is 28 and this side is 35? So could we use that to find y? All right, be careful which side's the hypotenuse. 35. So we're first going to do Pythagorean theorem. 28 squared plus y squared equals 35 squared. Okay, let's see if we can do the math pretty quick. Somebody with their calculator, what's 28 squared? 754? 84, thank you. Plus y squared equals 1,225. Okay, you guys just believe Kirsten here. She's typing it in for you. So write that down. Subtract your 784. Y squared equals what? 441. Take the square root. And what is the square root of 441? 21. Okay, so right now, make sure you are with me how we got y is 21. Everybody good? If y is 21, then what's the whole diagonal here? 21 plus 21, which is 42. Keep in mind, I'm going to say this again. If this were a rhombus, both diagonals would be bisected. But in a kite, only one of them is. So that means we know one of our diagonals is 42. And then we're going to have to do Pythagorean theorem again to find the other value. So I'm going to draw this and then we're going to stop, and at this point you should be able to figure it out from here. But are you guys with me that if I now know y, I could use this triangle? We found out y is 21, so I know 29, I know 21. Do you agree you could find x? Okay, and once you find x, you would add it to 28 to find your second diagonal. So I'm going to put diagonal 2 would equal x plus 28. And then we would just plug that in right here. We're running out of time, so I just want to make sure you understand the process. Are we good? Okay, here's what I want to tell you. We, on Tuesday when we come back to school, we're going to map test. I am not going to collect this homework on Tuesday, but if you wait until Tuesday to start doing your homework, you're going to forget all of this. But I do want to tell you that I'm not going to collect your homework until Thursday because we're going to map test Tuesday. So I'm just going to give you a lot of time to work on this homework and make sure you really understand it. You won't have any homework on Tuesday night, so start memorizing your formulas. I'm giving you a lot of time here before we move on because this is super important. The homework is not super long. I'm just trying to give you a lot of time to study. So right at the top of this, due Thursday. But do it this weekend, and then you won't have to worry about having any homework until next Thursday night, which would be awesome.